Okay, so like I promised last my part 2 of the video, I promised I was going to show you the practical for the semester, for the second semester. Practical I'll be showing you, well, everything is subject to change or to adjustment, okay, but they're the major practicals that will be done for the semester, are the major ones, okay. So I'm using the one that I use in my own time, 2013, and there are some updates on them, so the numbering may not actually be the same. But what I want to look at is just the title. So just take note of the title that you have here. So the first one we have here is experiment E1, which I think is the same E1 they have there also. So we have a voltage and current in the circuit, which is a Ohm's law experiment. So you can see it down here. Alright. So that is the first experiment that you'll be having. So I'll be going through them, like I have solutions to them. So if you need the solution, you can still let me know. Okay, I'll be dropping my phone number there also in these updates. Then you can always call me, join the WhatsApp group if you have not done that. And of course, I've made the WhatsApp group to be such that once you are subscribed, you can join free and get updates and practical teaching that I'll be doing even in other subjects. So you can see there the questions that I have there. So that is for experiment E1. Alright, the next one we have is experiment E2, which is resistance in series and in parallel. So of course we know that resistance in series, total resistance in series is usually higher than those in parallel. So they want to verify the series connection and then the parallel connection. The value you'll be getting at the end of the day, you compare them. Alright, you compare them. So if you see here, we have series values and then the parallel value I, V, and then I prime, V prime. Then plot a graph of I against V for both connection on the same graph sheets. Now this statement has been so confusing to most students. We are plotting on the same graph sheets, so 2 in 1. Determine the slope of the resulting graph, that is for parallel and for the series experiment, and then explain the difference in their slopes and relate it to the equivalence values of their resistance. So you are going to get your slope. Your slope is going to give you the total resistance in that series or in that parallel. And of course, if you use the formula, of course, the formula for total resistance in series is R1 plus R2 plus R3. Why for parallel is what? 1 over R1 plus 1 over R2 and the rest of them. So if you compare these two values, you're supposed to get the same thing, but it's a bit logical. So you follow my solution material and I will show you that. Now, I'll follow my solution class, I will show you that also. Stay to precaution taken to obtain accurate results. We've actually done that. Okay. Alright, the next one again we have here is potentiometer wire. Okay, potentiometer wire, which is what you have here, this A, B potentiometer wire. Now this is actually looking at two different things here. Here I'm going to plot a graph of I cross I prime versus 1 over R, which gives a slope of V square over R. Which give a slope of V square over R. So all the steps are all given to you here. Now let's go down here. You see the table of value. This is just from one of the students, which will still verify that what is correct. Like I've told you, I have table of values, verified one, which I'm going to give you later. Plot a graph of a product of I and I prime against 1 over R. Determine the slope and estimate the error in it. So I'm going to find the slope of the graph and the error in that graph. Okay, so we are going to see how these things have been done. Now, why is the current higher in parallel combination than in series combination? Of course, in parallel combination, the resistance is usually very low as compared to the series combination. I've already given you the answer, but join the solution class or get the solution material, and it just a 500 naira, be 1000 naira. You can get it at a cheaper rate if you actually subscribe to the YouTube channel. Now find the equivalence, the value of the resistance of the potentiometer wire from the graph. All these ones are done and will be explained in the next video. What will be the effect of increasing the area and the length of the wire on the current? Of course, you know that the resistance depends on the area and of course the area and the length of that wire. So we'll also look at that. Another thing here we have is E4, determination of EMF and internal resistance of a cell. Of course, you can see the setup here. Okay, so the table of value is also here, which I will see explain. We are going to go through them one after the other. So if you look at the values here, the resistance is increasing, the V value is also increasing, and then E minus V. Of course, the E is the electromotive force, which is the EMF of the battery. Normally, you are going to use a 2 battery, which is about 1.5, which is 3 volts. But you know now, due to normal stuff, now internal resistance, you are not actually going to get 3 volts. So you have 2.9. Okay, so the reading error, of course, if you measure 0.00, 0.1, any of them, So now E minus V. Now the truth is that the value of your E must be more than the value of your V, because the E is the true value of the voltage, while the V is the potential difference when you have connected it to the external circuits. Okay, so please, because these are the challenges most students have, I'm going to point out this very clear, because most students will tell you, will start having value, V value, I mean this column. The value you have in this column cannot be more than this 2.9. The value you have in this column cannot be more than that 2.9 you see there. So take note of that, because these are the things that I want us to know. It's not all about I can plot graph and no experiment I've done. No. That's why you need people like us to guide you. Like I said, I'm a laboratory technologist, University of Port Harcourt, a certified one. So whenever I do my thing, I don't just do it based on say you are an expert, you are that, you know. I do it based on the fact that you need to know the background and of course what you need to get through to make sure you have the best result at the end of the day. So these are the questions you are going to be getting. Plot a graph of this against R. Determine the slope of your graph. Find K equals to 1 over S. Of course, when you evaluate V against that R, we are going to get something unique. I'm not going to say that until I do the other video. And when you evaluate this, you also get another unique stuff. Now, D now says, what is the physical meaning of your K? Follow me through and I'm going to explain that. Still, for precaution you took in performing this experiment, and of course this precaution I'm going to give you in the electrical experiment will cover almost all the electrical experiment, and of course those in the optics experiment I'm going to give you cover for almost all of them. Now show that in this experiment V over E equals to R over R plus R for all values of V and E. Now you are going to use two ways. Is either you use the proving method or you use the value method. There are two ways we can use to verify this. Now state two sources of EMF other than the electrochemical cell. Ways where you can drive in currents or voltage in a source. Of course, you know your dynamo, the chemical cell, the solar energy, and the rest of them. They are one of the ways you can also use. So explain why a battery of 10 dry Laplacian cell, each of EMF 1.5 volts, cannot be used, of course, to start a motor car. Battery of 15 volts to start it. Of course, our battery uses 15 volts to start the motor. This thing we know, the LED accumulator we know is 15 volts. But why is it that you cannot use a dry cell like the Tiger battery that we all know? 15 of them, that 10 of them, or for 10 times 1.5 is 15. Why is it that we cannot use it to start that same car? We are going to explain that in our material and of course in our next video. So please get updated and also follow us as we move on. Okay, the next experiment is this, but last session, okay, this experiment, they skipped this very one and they actually did only this one, okay, but it was not actually done in this very textbook, in this very manual. They used another edition, okay, but it was still on the what do you call it, determination of unknown resistance using meter bridge. These are Wheatstone bridge and this is a meter bridge. Okay, so they left this one and they did this other one. So I don't know. They might just show you this E9, but they might end up doing a different thing, using it from a different edition entirely. They will give a photocopy of that once it is time. So we have the table here. Normally it's about a 2 graph or so you can see it here. So, but I'm not going to say anything much on this area, except if they actually do it accordingly. You know, they did exactly what we have here. So let's move on to the next one. Okay, so the next one we have here is an optics experiment. So we've gone through the electricity experiment so far. Any other thing that will be added, we can still include it later in our solution material, the videos that we'll be making afterwards. So this is from optics experiment, determination of focal length of a concave lens by displacement method. So you can see it here. All right, like I said, the numbering may not be, the L something may not be the same, but I think I have a list of experiment that was done last session here. E5, you know, E1, E2, L3, L2, E4. So you can see, have it there. I think these were some of the things that was done last session 2022. So we have it here. So this experiment, the values are usually very high, and of course there are some calculations you will do there. And in a different manual we have different questions that they ask. So but in this one, this is what we have here. They have additional questions they add to this one in one of the edition. So anyone they give you will still work on them. So you can see it here. These are the questions they have there. Alright, so you can see the graph. The graph is looking somehow horrible. So we'll look at them as we move on. Alright, next one we have here again, of course, determination of refractive index of a glass block 1. So we have different refractive index experiments, glass block experiment, rectangular glass block experiment we have here. So you can see it here. Alright, you can see it here. So these are the things you'll be recording. They'll give you the incidence rate. I'm going to explain this. I'm going to make videos on this. The incidence rate, which is this one here. So this is what they will be given to you. If you look at the steps, the procedures, they'll be giving the incidence rate. You understand? If you watch it, will give you the incidence rate 20, 30, 40, 50, 70, and the rest of them. Then in each case, you'll now be measuring your refractive index and of course the theta. Then you now find all these ones. Then later you do all the calculations you have here. So there are lots of things you need to know here. At times you look as if the work is very easy, but by the time you start the main work, you notice that you have a lot to do there. So please, let's take this very serious. Then this is another one again, determination of refractive index of a glass block 2. Almost the same setup, but different parameters are used to obtain. Of course, there are different methods, different formulas we can use to obtain refractive index. You understand? So the major different pattern here. So here they are using, of course, the same IR. Then here talk about Y tan I tan R tan I minus tan R and the rest of them. Then you measure the thickness of the block D naught. Then later you come here and then you do the calculation. I think this very one was done exactly last semester. So later question 3 says states next law of refraction. Explain what will happen when I is 90 degrees. These are popular questions in the O-level exams. So we'll go through them again. Alright, so we have block 3 here. Block 3 here. Yes, we have block 3 here. So refractive index 3. So we have everything here. The same pattern, the same result, just that different measurements pattern. Okay. There are various ways you can get refractive index of a glass prism. So different pattern of where you can get them. Different parameters you can use to evaluate them. So we have all this down here. So you can pause the video to check more what you actually want to cover up. And of course, you can't do without this triangular prism. Of course, we can't do without triangular prism. Determination of refractive index and angle of minimum deviation of a glass prism. Triangular prism has equilateral triangle prism. So you can see this, even the derivation too, very, very key. Those of you that are doing Phys 115, you need to know this because it's part of the exam. Now, funny enough, most of the questions we are going to be seeing in this particular physics will be appearing also in the exams. So you have to follow up as I explain them. So these are the steps you need to follow. These are the steps you need to follow to do the working. Okay, these are the steps you need to follow the steps accordingly. And then see the questions over here. So we are going to be answering these. What is the explain term dispersion? What is the significance of the U, which is the refractive index? Then explain with the sketch why a piece of coin placed at the bottom of a pool of water, of course, appear bent to observer at the edge of the pool. Of course, this is the concept of refractions. Okay, so we'll look at them. Okay, similar to that is what we have here also. L10 is also the same thing. It's also the same thing. If you watch this question are the same, but here we have two questions. If you watch the table of value of this one and this one, they are a bit different. So what we measure here, and then just an addition of d minus a, deviation minus the angle of emergence. The angle of emergence is the angle at which it comes out from here. This is incidence, refraction, deviation, and emergence. I will teach you, I'll tell you how to get all this stuff. Okay, teach you how to get all this stuff. So you look at the same question they ask there is what they see ask here, so almost the same thing we have there. So far I've taken you through the practical for the session. If there's any additional work, I will also include that in my solution material, of course, in my explanation in the video. So these are some of the solution material I prepare for some of the practical work, so you can see them. You also make requests for them to get them and then practice.